All right, today we're going to go ahead and get into relations and functions. And our objective for the day, I will represent relations and interpret graphs as relations. So go ahead and get that written down. And I'll give you a moment to get that written down. And then we'll go ahead and move on. So one more time, I will represent relations and interpret graphs as relations. So the first couple that we have here are actually review. So the first question says, state the domain and range of the given graph. This was something that we did in the previous lesson. So I want you to go ahead and take a moment and determine for me what the domain is and what the range is. Go ahead and press pause. Give it about 30 seconds to get this written down. When you're ready, go ahead and push play. All right, we see here that we have arrows going in either direction. So with regards to the x values, which is the left to right, it's going to continue in that direction through to negative infinity. And it's going to continue on in this direction to positive infinity. But as far as the range is concerned, it's not going up and it's not going down. It's staying consistent right here at your 0, 1, 2. So the range is at 2. How did you do? All right, next one. Go ahead and press pause. Take about 30 seconds. See if you can determine the domain and the range here and come back and we'll see how you did. All right, so for the domain here, again, we see those arrows, and the arrows are going in the left-right direction, so this way is my domain, and because of those arrows, I know it's going on continually. So hopefully what you wrote down for this one is the domain is negative infinity to positive infinity. The range is my up and down. And again, you'll notice because of the arrows on either side, that as x gets larger or bigger, that y continues to get larger or bigger. So it is also negative infinity to positive infinity. Let's try another one. Okay, with this one, notice or remember that these boxes are a little different. And looking at this, we talked about it yesterday. I'm going to have you write it in a little bit different way than we did before. And I want you to write it here. So the domain I'm looking is anything that is greater than or equal to negative 2. And coming to this side, 1, 2, 3, 4. And anything less than or equal to 4 is how you're going to state that domain. So that way it includes everything from negative 2 to positive 4. As far as the range is concerned, it's negative 1 greater than or equal to y, which is up to 1, 2, 3, so greater than or equal to 3. So that is a new way to write it. Make sure you write that down. And we'll go over that again on a future lesson and in the review. So let's get started with today. What is a function? Well, a function is a rule that establishes a relationship between the input and the output. And for each value of x, there is exactly one output of y. Whereas a relation is just any set of ordered pairs. So something can be a relation and not be a function, but if it's a function, it has to be a relation. So let's practice some of this. So the first thing here we're going to learn is about the vertical line test. And it says the graph is a function and it will pass in a vertical line test. So take your pencil. And you can see here that I've got something that looks kind of like a pencil. It's just arrows going up and down. I want you to hold your pencil on the paper as this arrow is up and down. And so as we're going across with this, notice that as I move it, never once does it hit the line that I'm moving across more than one time. So in this case, this is a function. Whereas if we take this same pencil and we go across, can you see how when I'm going across, that say right here and right here, that line is crossing what is drawn on the graph. So this is not a function because it hits more than one point. And it actually does it many times. If I were to move the stick over, now I'm looking right here and right here. So there's many points at which it hits more than once, which makes it not a function. So I want you to go ahead and determine which of the following graphs represents a function of x. Please press pause, decide whether or not they are or are not a function, and come back when you're ready. All right, let's go ahead and see how you did. So here I've got my pencil, moving it across, and I see right there, and actually in many places, it hits more than once. So is that a function or is it not? And hopefully you answered that it is not a function. Let's continue moving across. So taking it, we've coming across here, and wow, look at there. It hits it here, here, and here. So 3 times where it hits at the same time, which makes this not a function. The next one, as we go across, hitting only once, keep going, keep going, keep going, keep going. And for that, it never hit twice at any given point when bringing my pencil across. So this one is a function. And finally, the last one, I can go across, 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 and it's very obvious that it only hits my pencil one time at any given time. So this is also a function. All right, you go ahead and try these next ones. Go ahead and list which ones you believe are functions and which are not. Press pause, come back to me when you're ready. All right, looking at this, going through number 1, function or not a function? Going across, is a function. Going on to the next one. Going across, oh, look, right there, we've got twice, is not a function. Going with the third one. Going across, across, never hits more than once, so it is a function. And here, going across, looks good, up, then we hit right there. And you can see that I actually, in many points, hit it here, so it is not a function. And how'd you do? All right, another way that we can determine whether or not given values are a function or not is by looking at their tables. So looking at their tables, if we look at it and try to graph it. So if I look at number 1 and I have a graph, it says 1, 1, 2, 2, 3, 3. So it's going to look something like a straight line. So it is a function. Everything's good. Passes our pencil line test. Here's another graph. I've got 1, 5, 2, 4, 3, 3, and 4, 2 coming down. So it just looks the opposite, but it is also a function. Now, let's look at number 3. I've got 0, 1, which is right there. I've got 1, 2, 3, 2, so right up there. I've got 5, 3, so it's up there. It looks good so far. And then I've got 3, 4, which is right there. So looking at this, the line goes across like this. And if I look at this little spot right here, notice it crosses more than one time with our pencil line test, so it's not going to pass. And what makes it not pass is that X repeats itself with a different Y. Now let's look over here where there are 2 values of Y and 2 values of X. So because of this, I already know that both 3 and 4 are not functions. Okay, the next one, I can see here, 2 is repeated, Y is different. So number 5 is also not a function. Number 6, what number repeats itself there that make this a function or not a function? And the answer here would be the 10. So it is also not a function. Number 7. Now, looking at this one, it's 1, 2, 2, 2, 3, 2, 4, 2. How about that one? If I look at my vertical pencil line test coming across, it is a function. So it's okay for Y to repeat itself, but X cannot repeat itself and have different values of Y. And so looking at number 8, it is not a function. Number 9 does not repeat itself, so it is a function. All right, so this is how our input-output charts look. And you can see here that the lines, it only goes across once. It's okay for Y to repeat itself, so this makes it okay. But what does not make this a function is right here. See, the input is repeating itself with different values of Y, so this is not a function. Here, see how it's only leaving once? It's going over here twice, but it's okay to repeat the output, so this is a function. Right here, it's leaving 2 and going to both 2 and 4, so it is not. And here, all of them are leaving and going to 5. That's going to look like that. And so it is a function. All right, for a set of points, determine whether or not X is, if there's exactly one output, is it a relation or a function? So here, X never repeats itself, so it's a function. Here, I've got -1, -3, 2, -3. -3 repeats itself with different values of Y, so this is a relation. Right here, -5, -6, -7. X does not repeat itself, so it is a function. And so the only one that is not a function is number 2. And this one I'm actually going to go through in class. So we're going to go ahead and end it here. I'm going to have someone actually hand out the assignment, and that's what I want you to do with the rest of your time. If there were parts that you did not understand, please ask the substitute to rewind back so that you can look at it again. And you can ask me any questions tomorrow when I'm back. Thank you.